Welcome to our deep dive into the St. Petersburg paradox, a fascinating problem in probability theory and economics that has puzzled mathematicians and economists for centuries. If you're curious about why people behave differently than what classical economic theory predicts, you're in the right place. The paradox was first introduced by Daniel Bernoulli in 1738. It presents a game of chance, which seems to have an infinite expected value. But in reality, no one would actually pay a large amount to play it. Let's walk through the basics of this paradox. Imagine a game where you flip a fair coin until it comes up heads. The payout of the game is determined by the number of flips. Specifically, you win $2 raised to the power of the number of flips it takes to get heads. The formula for calculating the expected value, EV, of this game can be expressed as. To simplify, we look at how each additional flip adds to the expected value. First flip, heads. 1/2 probability. Payout $2. Contribution to EV equals $1. Second flip, tails then heads. 1/4 probability. Payout $4. Third flip, 2 tails then heads. 1/8 probability. Payout $8. And so on. If you add all these contributions, theoretically, the expected value, EV, sums to infinity. Now, while mathematically the expected value is infinite, think about what you would actually pay to enter this game. Most people would hesitate to pay even $20. This brings us to why the paradox is indeed paradoxical. People intuitively value amounts based on diminishing marginal utility rather than linear expected value calculations. Economists and psychologists have suggested several explanations for this paradox. Bernoulli himself proposed the concept of diminishing marginal utility, which posits that the utility gained from each additional dollar decreases as wealth increases. In other words, an extra $100 is far more valuable to a person with $1,000 than to a billionaire. Consider an example where John, who has $1,000, values an extra $100 more significantly than Jane, who has $1 million. Therefore, the actual utility he gains diminishes as he gains more. The introduction of risk aversion offers another perspective. Humans are generally risk-averse, meaning they prefer a guaranteed outcome rather than a gamble, even if the mathematical expected value of the gamble is higher. For example, most people would prefer a guaranteed payout of $50 over a 50% chance to win $100, even though the expected value of the gamble is also $50. With these concepts, economists have proposed utility functions to model human behavior more accurately. One commonly used model is the logarithmic utility function, where the utility U is defined as, for example, if your wealth is $1,000, the utility you derive from it would be log 1,000 equals 3. If your wealth doubles to $2,000, your utility is log 2,000 equals 3.301, showing a diminishing return in additional utility. Let's consider a few questions to test your understanding. 1. What is the expected value of the St. Petersburg game? 2. Why don't people agree to pay a large amount to play this game? 3. Explain Bernoulli's solution to the paradox. 4. What role does risk aversion play in the St. Petersburg paradox? Answer to question 1. The expected value of the St. Petersburg game is theoretically infinite, given the probability and payout structure. Answer to question 2. People are unwilling to pay a large amount to play because they experience diminishing marginal utility and are generally risk-averse. Answer to question 3. Bernoulli's solution involves the concept of diminishing marginal utility, where the value of additional winnings decreases as wealth increases. Answer to question 4. Risk aversion means people prefer certain outcomes over gambles with high expected values, leading them to undervalue the game's theoretical payout. I hope this deep dive into the St. Petersburg paradox has helped you understand why this thought-provoking problem continues to captivate scholars. Understanding human behavior in economic models not only provides valuable insights into academic theories, but also offers practical applications in making better financial decisions. Thank you for watching. If you found this video helpful, don't forget to like, subscribe, and hit the bell icon for more finance and economic analyses. Until next time, stay curious and keep learning.